tackle about network communications and protocols. There are some simple binary arithmetic. Working with IP address, especially for subnetting in supernetting, which is covered later in this section, so we need to master the different kinds of binary calculations. First, converting between decimal and binary. This is extremely easy if you don't mind thinking mathematically. And this is the decimal to binary conversion table. The first two rows are the binary and exponent values of each bit position of an 8-bit number. The third row is what you complete to determine the binary representation of the decimal number. Second, converting binary to decimal. If you know your powers of 2, here's the recipe using 11011011 as our example number. Count the total number of digits in the number. 11011011 has 8 digits. Subtract 1 from the total. 8 minus 1 equals 7. That number 7 is the power of 2 to associate with the highest exponent 2 in the number. Convert to exponential notation using all the digits as multipliers. So, we proceed to high-order bit patterns. High-order bit patterns. Subnet mask always consists of consecutive first and zeros. You will never have, for example, a subnet mask that looks like 10110001 in binary, 177 in decimal. Each octet in the subnet mask will always have zeros or more firsts, followed by more zeros. So, this is the table of high-order bit patterns. Low-order bit patterns. We stand the previous example on its head and start counting up through the 8-bit numbers from right to left, adding ones as we increment. Calculating a subnet mask. To decide how to build a subnet mask, if you follow this recipe. And here's the recipe. Second, another subnet mask example. Let's pick a more ambitious design this time, one that shows how subnet mask or host address can extend across multiple octets. Creating supernets. The act of supernetting steals bits from the network portion of an IP address to lend those bits to the host part. As part of how they work, supernets permit multiple consecutive IP network addresses to be combined and make them function as a single logical network. Incidentally, these patterns meaning more hosts to be addressed on a supernet than the combinations of multiple addresses might suggest. Here's why. Network address translations or NAT. Network address translations, the remapping of one IP address space to another by modifying the network address and information of packets, IP headers while in translate across a router. This method allows for the use of a single IP address on an entire private network. Helps considerably more by allowing the private IP addresses to be used by an organization while being connected to the internet. Dynamic Host Configuration Protocol, or DHCP, is a network management protocol used to dynamically assign an Internet Protocol or IP address to any device or node on a network so they can communicate using IP. Dynamic Host Configuration Protocol, or DHCP. Some drawbacks to using TCP, or IP in large network, include the detailed configuration of all devices, keeping track of assigned addresses and into which machine they were assigned and so forth. To make this process easier, the Dynamic Host Configuration Protocol, or DHCP, was developed. NetBIOS and NetBIO. NetBIOS is a programming interface that allows 1/0 requests to be sent to and received from a remote computer, and it hides the networking hardware from applications. NetBIO is NetBIOS Extended User Interface, a transport protocol designed by Microsoft and IBM for the use on small subnets. NetBIOS and NetBIO. In the early 1980s, IBM hired a third-party company named Cytec to build a simple, basic set of network programming interface. The result became NetBIOS. This interface persisted much longer than anyone expected and remains in broad use today. On the cable access methods. Given that computers communicate in a number of ways, some function must be considered in network communications, including how computers put data on the cable and how they ensure that the data reaches its destination undamaged. Functions of access methods. When multiple computers are attached to a network, the way those computers show the cable must be defined. When computers have data to save, they transmit data across the network. Major access methods. Channel access is handled at the Media Access Control MAC sublayer of the data link layer in the OSI model. There are 5 major types of channel access. First, contention. Second, switching. Third, token passing. Fourth, demand, priority. Fifth, polling. The first major access method is contention. Contention is conflict when two or more programs try to use the same resource or settings at the same time. Second is switching. A network switch is networking hardware that connects devices on the computer networks by using packet switching to receive and forward data to the destination devices. Third, token passing is a channel access method where a signal called token is passed between nodes to authorize that inside to communicate. And fourth, demand priority. Demand priority is a media access method used in 100 base VG, a 100 megabit per second Ethernet implementation proposed by Hewlett Packard and AT&T Microelectronics. And fifth, polling. Polling is the process where the computer or controlling device waits for an external devices to check for its readiness or state, often with low-level hardware. Choosing an access method. The access method is an integral part of your network. The biggest factor in the choice of access method is the network topology. A ring topology network generally uses the token passing channel access method.